Okay, so the title of this is because levels, sublevels, orbitals, and electrons is because you have to be good at the vocabulary of this unit to understand the questions that are being asked of you. And if we don't do this today, you will never get a firm grasp of it. So we're going to talk about the differences between those four terms. So the first thing we're going to talk about is energy levels. Energy levels can be numbers 1 through 7. Hypothetically, they could go higher. And their energy levels are like rings on a Bohr model. The Bohr models that you drew in junior high, where you had like the nucleus, and then you had rings like this. And how many went in the first ring? Do y'all remember? 2, and in the second ring? 8, and the third? Okay, so now we're going to learn that was a lie. The first is still 2, and the second is 8, but the third one is not. Okay, so energy levels. Okay, let's back up a second. The electron cloud is the general area, like gives you a general idea of what I'm talking about. So think of the term electron cloud as being like the neighborhood. If I said I live in Firethorn, you know a general idea of where I live. Would you agree? Yeah. Okay, and so energy levels are like your street. So they're getting more specific than just saying I live in Firethorn. If I tell you that I live in Firethorn and I live on blah 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 street, okay? So that is just letting you know how far those electrons are away from the nucleus. Is it really close to the nucleus or is it further away? That's pretty much all you're saying with an energy level. Okay, within energy levels, we have something called sublevels. Okay, and those sublevels are S, P, D, and F, which you drew on your periodic table yesterday. So the sublevels, if the electron cloud is your neighborhood and the energy level is your street, what would we say the sublevel is? Your actual address, right? Your house where you live. Okay, so the sublevel, we're getting more and more specific as we describe this stuff. So it is like your house. And within that, we have, it could be an S, a P, a D, or an F. Okay, those are different floor plans, you know, different shapes of houses. Okay, does anybody remember from the original notes what an S orbital or S sublevel looks like?
In the funny boarding house model or the actual?
In the actual notes we took. It's okay if you don't know. The notes y'all were supposed to take at home, it's a circle, so it's a sphere.
Oh, yeah, I remember that.
Okay? It is a sphere. Okay? And then the P looks like a dumbbell, which people will tell me looks like an 8. Sort of, yeah. Looks like an infinity symbol. Okay? It looks like a dumbbell. That's what most chemists say the shape looks like. Okay? And then the D looks kind of like a flower. Good. And you have to know that these are very crude representations of what they actually look like. And then the F is very complicated, and it goes in all 3 directions. It's really hard because it's all 3-dimensional. So it looks like a really fancy flower. We call that complex. Okay, so we'll talk more about the shapes later, but you do need to know the basics. You need to know, like, which one is a dumbbell shape, which one is a sphere shape, which one is shaped like a flower. You do need to know the basics, okay? But I'll show you a little bit more of what that looks like in 2 and 3 dimensions. So, again, let's back out. We went from the electron cloud is your neighborhood, the energy level is your street, the sublevel is your house, and so what is an orbital? The room that you live in the house. Okay, good. So we're going to come here, and within sublevels we have orbitals. We're getting more and more specific as we go. Okay, this is like your room. Okay, the smallest location of an electron. Smallest location that we can talk about for an electron. So there's a maximum occupancy for this. What's the maximum occupancy of an orbital? How do you remember that? The boarding house thing had 2 per bunk, and the orbital diagram within that same pogle had 2 per square, right, or box, okay? And so the maximum occupancy is 2 electrons, okay? Remember, those 2 electrons must be facing different directions. So it's just a way, like I said, to help you guys get a handle on what these things mean to scientists, why they're describing them this way. We actually go into quantum numbers, which I really like. I used to teach them to my kids, but they are not even required in AP Chem anymore. But quantum numbers to me really made kids understand this really well once you kind of understood how to do them. So it's just so you understand that when we're describing them, when we're describing that something is in the 3D sublevel, we're describing that it's the 3rd energy level away from the nucleus, and it's housed in that D sublevel, and how many can be held there, and all that kind of stuff. That's what we're going to practice today. All right, keeping on your next page, or if you're with me, or if you're on your own page, whatever, sublevels continued. So we're going to talk a little bit more specifically about sublevels. Okay, so an S sublevel, okay, it has only 1 orbital. And this 3-dot triangle that I use, that means therefore in shorthand. You may someday have a job where you use shorthand, but I learned that from somebody else and I like it. So the S sublevel has only 1 orbital, and if it has 1 orbital, what's the maximum number of electrons it can hold?
2.
Holds 2 electrons. Good. Okay. It's only going to hold 2 electrons. Sublevel. This is where you're going to look at your colored periodic table to help answer these things. Oops. Sublevel. Okay. Has how many orbitals? Therefore, it holds how many electrons? Okay, talk to your table. Look at your p sublevel and figure out how many orbitals one p sublevel would have and how many electrons it would hold. Okay, if I'm looking at my colored periodic table, the P sublevel has 6 spots. Okay, that means it can hold how many electrons? It can hold 6 electrons. And to hold 6 electrons, I would need how many orbitals? 3. I just need to divide by 2, so that gives me 3 orbitals must be present there. He has 3. Mm-hmm. Okay, the next one is your D sublevel. It has how many orbitals? Don't answer out loud. How many orbitals? And therefore holds how many electrons? And you can work it backwards. Like I said, you can start with electrons and work backwards. That's fine. So figure that one out. How many electrons can a D sublevel hold? 10. It can hold 10, so it must have how many orbitals? 5. Good. Okay, and then F blank orbitals. Therefore, it holds how many electrons? I know it seems tedious to write all this down, but there's a reason I'm having you write it, because you're going to refer back to this. When you're stuck later and you forget, you're going to be like, oh, I can go back and look at my notes, because this is one of those things that the wording catches you. And that's why we're going to practice the wording here in a minute, is you got to know the difference between, that's about an energy level, a sublevel, an orbital. All those things are new to you. So how many electrons can be held in the F sublevel? 14. So how many orbitals does it have? 7. Good. Okay. So that being said, the reason we're talking about that specifically today is we're going to do our orbital filling diagrams. That's the one with the boxes and the arrows. We're doing that today. You're going to do it on your own for the first time. Okay? So let's talk about how we would draw them. In the POGL, they had boxes, but I find that boxes are they can make for some really sloppy work for students. So you're having to draw a box, you're drawing arrows in the box, and it kind of gets messy. So I just draw it with a line underneath it. Okay? So let's talk about how many lines we would need, because if a box represented what again? A box represented an orbital, okay? So a line is going to represent an orbital. That's the only difference. We're just going to change it to a line. So if you have an S sublevel, it will only have one line, because you just told me it only has one orbital, so it gets one line. Okay. And so a P, how many is a P going to have? You just told me. So you're telling me a P has
3.
Yeah. So 1, 2, 3. I would draw 3 lines if I'm drawing a P orbital. And I know it seems ridiculous for me to have you draw it, but I promise it's going to help you remember. 1, 2, 3, 4, 5 for D. And for F, you would need 1, 2, 3, 4, 5, 6, 7. So we are going to do a lot of things in this next practice. It's going to go quick, but we're going to review electron configurations, shorthand version of electron configurations, how many valence electrons do they have, where they're located. We're doing a whole bunch right here. It's a lot of bang for your buck on this practice. All right, so our first one is going to be beryllium. First, I need you to write. I don't want you to go past me. I know some of you can go 6 times my speed, okay? That's not the point. The point is just hang with me right now. So write the electron configuration for beryllium. I'm going to ask you to tell me what to write. Yes, the ritual chant. Yes. And make sure you sound as miserable as possible when you're doing the ritual chant. Last period was like 1s, 2. I was like, okay, fair enough. It's like birthday. When people sing happy birthday, they sound miserable. Happy birthday. It sounds like you're going to a funeral. It drives me nuts.
Well, each birthday gets you closer.
Well, you're not wrong. Okay, so everybody together, like you like it. Y'all listening, girls? Okay, everyone together. What is my electron configuration for this? Y'all are brilliant. Okay? So I have 2 S sublevels, so I have to have 2 lines, one for 1s, one for 2s. Now, what is the rule about how you fill up, the order you fill them up in? What's the rule called? Anybody remember? It is a German word. Aufbau. Okay. So we have to fill the 1s before we're allowed to go to the 2s. So I'm going to fill it up. 1, 2, up, down. And then up, down. That's 4 electrons represented. I had 4 electrons here, so we're good to go. So my question for you now is, where are the valence electrons located?
2s.
The 2s. Good. So I want you to circle them. And we're going to say those are the valence electrons. So how many valence electrons does beryllium have?
2.
It has 2. Very good. Okay, do we have any unpaired electrons? Are any of them not paired up with a partner?
No.
Nope. So if I ask you on the quiz, how many unpaired electrons does beryllium have? You have to draw the picture, and then you say, oh, it has no unpaired electrons. Okay? Next one, let's do oxygen. Your electron configuration. Okay, what is our electron configuration for oxygen?
3, 2,
What?
1.
Oh, go ahead.
1.
Brilliant. Okay? So let's circle our valence electron. Oh wait, not yet. We have to draw them out. Okay. So I have a 1s and a 2s. So I'm going to draw a line for 1s, a line for 2s. How many lines do I need for P? 3 for P. 1, 2, 3 all together. Oops, sorry, I wrote that as 3P. That's 2P. Yes, I do expect you to label underneath these. Here's what boys will do. Okay, I'm going to call you out. Boys are like, you'll do this, and then you just mix them all together. I have no idea what's going on. And I'm like, which is which? Like, what are we doing here? So, we have to create some separation and show what we're doing. Okay, I got to put 2 in my 1s, 2 in the 2s. And then I'm going to come over here. And now, what is the rule about how you fill them in when you don't have them all filled? Okay, so we have to go, I go up, up, up first. Up, up, up. That's 3. I need 4, so I'm going to come over to my left and come down. Okay. So, I don't have to look. How many unpaired electrons do I have? I have 2, so let's circle those. These are unpaired electrons. Okay, and then my valence electrons, what am I going to circle? 2s and 2p. So those are my valence electrons. So again, if they asked you on the quiz, you could say, how many valence electrons does oxygen have? Well, now we know 1, 2, 3, 4, 5, 6. Okay, how many unpaired electrons does it have? We know it has 2 unpaired electrons. Yes? What do you mean 3 lines?
There were 3 boxes in the bottom.
Right, there's 3 orbitals the P has. So we have 1, 2, 3 lines for the 3 orbitals. Okay?
The paper meant 3.
Okay, last one we're doing. Let's do cobalt, and you're doing the long version, not the shortened version. Do the long electron configuration. It's not that long. Oh my gosh, it's number 27. It's not even that long.
That's so much.
Just do the electron configuration. Do not pass go. Do not collect $200. Just the electron configuration. Check with your neighbor when you're done to see if you guys got the same electron configuration. I better not be working ahead of me. Look, even CT's not working ahead of me. Okay, what is our electron configuration?
1s2.
I heard most of y'all say it correctly. It's 3D7. Remember, the D's are always one behind. Okay, the D's are always one behind. Okay, now this is my time to review you on the shortened version. So let's do the noble gas configuration of it. Okay, so what do I have to go back to for the noble gas? Argon. So, see, I have a plan for everything, how to review y'all. So it's argon, and then what do I write after that?
4s2.
Okay, so what do I circle for valence electrons here? 4s2. You better be doing this in your notes. Valence electrons. Okay. Because it's not the biggest number in front. Remember, it's in the third energy level. Those D's and F's, they get tucked in. Even though they get filled later, they get tucked inside like the outer stuff. That's just the way that they're made. Okay, last little bit when you do the orbital filling diagram, we're going to do the shortened version because I'm not mean. So argon, you still have to put the argon, and then you need to put your 4s, and then how many lines am I going to draw for D? It goes 1, 3, 5, 7. So 5. 1, 2, 3, 4, 5. And if you're cool like me, you can do that. If you're fancy, I know, don't be jealous of my skills. Okay, and now we got to fill them in. We got 7 electrons, and we're going to fill them up first. Oh, wait, sorry. Oh, I almost violated alpha's principle. I didn't do 4s first. 1, 2. And now I can move on to D, which has 7. Up, 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 up. That's 5. Come back to your left and go down, down. So how many unpaired electrons do we have here? 3. Okay. Okay. So I'm going to pass out the worksheet we're going to do here in a sec. So we're going to move on to this worksheet. Now, you have to read the prompt every time. Worksheet, I'm going to teach you how to read the worksheet, which sounds really silly because you can read, but y'all will get confused. Okay, this is the prompt every time. You read the bold, and then you read, every time you go to another one, you got to reread the bold, make sure you're reading the right thing. Which energy level, 1, 2, 3, 4, 5, 6, 7, holds a maximum of 8 electrons? So you're looking at your periodic table. Which energy level holds a maximum of 8 electrons? Talk to your table. Okay, let's talk about it. What's our answer? It is energy level 2. It's not 3. Why is it not 3?
Because 3 also has.
Because 3 also has the 3D. Okay? So energy level 1 can only hold 2 electrons. Energy level 2 can hold 8, which you learned in junior high, but now you can see a little bit more about why. And then energy level 3 can hold how many? 18. So you see, that's where the junior high teachers lied, because it wasn't really 8. But it's okay. Okay. Which energy level contains only an S sublevel? 1. Good. Which energy level is the first to have an S, a P, and a D sublevel? 3. Good. Which energy level is the first to have a P sublevel? Good. Which energy level is the first to have an F sublevel? It's 4F, so the first one to have an F sublevel is 4. Okay. Which one holds a maximum of 18 electrons? 3. Okay. So you're going to do this like this. You're going to work down the rest of the worksheet. I have a key up here for you to check your answers. But do that. Then at the end of that, you have notes on Canvas and work on Canvas to do.